My name is Sheeri Cabral. I am a MySQL DBA, Senior DB Admin Architect at Mozilla. There's a Firefox in every single one of my slides because it's awesome. Let's see, Twitter I'm at Sheeri. I have a blog at Sheeri.com, which pretty much just feeds from the Mozilla blog because it's easier that way. If you want to download these slides, because I know that everyone's like, hey, download the slides. It's there. Usually I actually have a QR code in that big slot there, but because... So talk about making mistakes. So you actually asked, how do you prepare to make mistakes? I would say the best way that you can prepare to make mistakes is to not be a jerk. Because I left my laptop at Boston's Logan Airport, and I tweeted about it. I was like, oh, I can't believe I'm such an idiot, whatever. And I had like 5 people, no fewer than 5 people say, what can I do? Can I need help? Do you want me to drive in a car and drive? Like, I'm in the area, I'm half an hour away, I could drive if you need something. So this is a presentation on a loaner laptop. You know, yes, it was great that my presentation was saved in the cloud somewhere, so it was really easy to get to. But I think the best way to prepare for mistakes is to, you know, have good relationships with people so that if a mistake does happen, they don't make it on you personally, right? Everyone makes mistakes. If you make a mistake and you're a jerk about it and you're like, oh, well, that wasn't my fault, that was totally this, and that, people aren't going to want to work with you and they're going to start assigning it to you as opposed to like, oh, yeah, that's Sheeri, she just made a mistake. You know, as opposed to, oh, God, I can't believe Sheeri made another mistake. So, which is how I feel whenever I make a mistake. And one of the tweets in my head that I didn't actually tweet yesterday was, if only I could be as forgiving and loving as the community around me. Because like nobody else is like, gosh, that was a brain dead thing to do. And me and I still like, how did I leave it there? Anyway, this all has nothing to do with my topic, which is called Optimizing Queries with Explain. Explain is a MySQL extension, which is actually starting to talk about my things. It's an SQL extension to MySQL, so it's only in MySQL. It's not in any of the standards, ANSI standard or ISO standard SQL. It's only for select, although that's changing in MySQL 5.6. And what that means is if you run this command, you can only run it put it in front of an select query. But you can modify other statements that are updates or deletes and change them into selects so that you can do that. For example, if you have an update statement, you can actually change it to a select statement and then put explain in front of it. So, and how you use explain is you just put the word explain in front of your select query. In MySQL 5.6, which is not GA yet, but will be probably in a couple months, this all changes and you can use it in front of deletes and updates. So, what does explain show? So what's the point of using explain? I talk about how you can optimize queries by using explain, but the reason you can do this is because explain gives you a bunch of information that you can then use to figure out how to optimize your query. It doesn't actually tell you how to optimize your query, it tells you what kind of algorithms are going to be used to execute your query. And so if you think that those algorithms are not optimal, you can write your query in a different way so it will use different algorithms. So what does explain show? It shows how many tables you have, or how many virtual tables, or how many kind of underlying tables you have, how tables are going to be joined, if you have any joins, how the data is looked up, and this is actually the biggest one, because how the data is looked up, if it's a range or if it's an exact match, that's really one of the biggest keys to it. If there are subqueries, unions, or sorts, it'll show that. If where or distinct are used, so if you have a where clause, that's usually good because you want to filter out your data. Possible indexes that could be used, actual indexes that are used. So if you have a query and you're like, oh, it totally should be using this index, and it doesn't even come up in the list of possible indexes, you have to figure out why that is. The length of the index that's used, so longer indexes take longer to search. That doesn't mean that you should put all of your data into like a 1-byte integer, but it does mean that if you have, you know, a GUID instead of a number as your primary key, that will take longer to search. And the approximate number of records examined, which is pretty useful, because if you think, oh, you know, 20% of my data should match, and you're not getting that at 0 approximate records, it's something to look at. So, metadata. I once had a talk where I went through all of it was a 3-hour talk, I went through all of the data, all of the metadata that MySQL had to offer at the time, and it was called I Never Met a Data I Didn't Like. I have the worst database jokes. It's great. So the MySQL optimizer uses the metadata about cardinality and number of rows and selectivity and all that stuff to figure out all these algorithms. Now, why is that important? Well, the important thing is that if you're using InnoDB, which is one storage engine in MySQL, it's the default in MySQL 5.5, and it's not in earlier ones. It's the transactional storage engine. It uses approximate statistics. And the last time I checked, it only has one method of doing dives into the numbers. So if you do an analyze table, which will rebuild the statistics, and you do it and you don't like the results you're getting, and you do an analyze table again, it's going to do the same thing. It dives into like 4 pages, gets some data, and comes back out, but it's not really randomized or anything like that. MyISOM has better and more accurate metadata. It's exact metadata. So for example, if you want a count star of the table, it's actually just stored in the MyISOM metadata. It doesn't have to do any work at all. It just goes to the metadata and gets it back. With MyISOM, if you do a count star, it actually goes and goes to an index and does a full index scan to actually count the number of rows in there. So that's just important to know. It may be a factor in choosing one over the other. Usually people want transactionality. MyISOM is not transactional, so usually it's not a big deal, but it's something to know that InnoDB has approximate statistics, because if you're sitting there ripping your hair out and going, why isn't MySQL using the index I want it to, that may be why. So this is what explain output looks like. Now, you get one of these. See how this says one row? You get one of these per table or derived table that's being used in your query. So it returns 10 fields by default. And here's just something. So there's this. There's a sample data set called the Sequila sample database. Sequila being the name of the dolphin. That's the logo for MySQL. And it's a video rental store. Anyone here remember video rental stores? It's not just the data that's out of date, it's like the entire concept. So we used to have these things. Anyway, so, but basically, so here's a query that we were just saying, okay, well, if you have this rental ID, what's the return date? Okay, and this is what it would look like. And I'm going to go through each one of these fields, so, but that's just kind of what it looks like. So the first thing is a sequential identifier. It's an ID. The name is ID. And it's just one per table, one per subquery, one per derived table. If there's a view, if you're using a view in MySQL, there's no row returned for that particular view. Now, the view in MySQL is just a query. So the query probably uses a table. It doesn't have to use a table, but usually it would use a table. Maybe you're doing some joins or whatever. So you would actually have one row for each underlying table in your view. Now, this is important because some DBAs like to obscure a lot of stuff or whatever. They're like, well, we don't need these developers to know what's really going on underlying. We're just going to make views for them all. And then all of a sudden, this simple query that you're like, select, whatever, return date from rental where rental ID equals, 1, 2, 3, 4, 5, and then you end up getting like 7 rows back. And you're like, isn't rental just a table? Like, well, maybe not. Maybe it's a view with underlying tables. So that's what you get. Select type, and that's not really important in the grand scheme of things, just to know how many you have. The next row you get. Oh, actually, you know what I didn't talk about? This \G. So I have a couple of tips I like to give people. Who here actually uses MySQL? Okay, could you guys know about \G? So \G gives you this awesome vertical format, right? It's not, each one of these is a field. So instead of like having the ID here and then select type and then table, it's actually doing that in vertical format, which is really awesome when you have a wrap line. The other tip I'll give you, so that's \G. If you do \G, that just gives you the regular same thing as semicolon. The other tip I'll give you is that if you're writing a query and you want to like cancel it halfway through and you've hit Control-C and you're like, oh god, that cancels out of MySQL, I hate that. Well, what you can do is actually \c. And so you can type this whole query and whatever, and you realize, oh, I forgot like a where clause or something. You hit \C, enter, and it doesn't actually execute. So those are my 2 tips. If you learn anything today, the \G will probably be like the one thing that you're like, oh, that's the best thing I learned today, at least in this talk. So select type. This is kind of a very, it's an interesting one, but usually it's going to be the same thing over and over. Usually it's going to be simple. or primary or something like that. Usually it's simple because it's just one table or a bunch of joins. If you're doing something a little more complicated, you might see primary or union result. So if you're doing a union query, you're taking two or more queries. Let's say you're doing two, you're doing a union of two. You'll actually have 3 rows. You'll have the one query, the second query, and then the result itself is its own kind of table when it's putting the results together. So there are different ones there. These are not really the interesting ones, but you can see here's a union query. Explain select first name from staff, union select first name from customer. You can see select type is, let's see, I don't get a pointer here. Okay, select type is primary on the first one, select type is union on the second one. So the first one you get primary, the second one you get union, and the third one you get union result, even though there's only 2 tables there. So other select type output is used in subqueries, and we'll talk more about subqueries later. You might see things like dependent union, dependent subquery, derived for a derived table, uncacheable subquery, which is just as sad as it sounds. It's poor uncacheable subquery. So the third one is table, and this is where we start getting into like the real information here. Now here, it returns the name of the table that you use or the alias. Now here's where, when someone comes to me and goes, Sheeri, can you optimize this query? And then gives me like this page long of stuff where everything is aliased to like A, B, and C. What you see in the table is either the table name or the alias if there is one. So here, you know, because we're just doing from rental, you see the word rental. Great, I know what table that is. If I had said from rental as A, or as R, for example, which is a lot of people do, then it would say table R, which is not really helpful when you have like, you know, 7 different rows you're trying to look through. So that's something to consider when you're making your aliases. They're a little hard to follow in long explain plans. You might see null here. Now null is if there isn't a table here. And there are some very good reasons for not having tables there. For example, if you do explain 1 plus 2, you can do that. There's no table. It doesn't use a table. Or if you have a query that's not, that's impossible. So for example, in this data set, the rental ID started at 1 and went up. So if you actually did an explain return date from rental where rental ID equals 0, it goes to the metadata and it goes, I don't even need to go looking at any data because this thing starts at 1 and you had something under it. So I'm not even going to go to the table. So if you have null, it doesn't go to a table, which can be really fast, but probably not what you're looking for most of the time. Now we get to the real meat of this, the type. Type is the data access method or the data access strategy. And so that's kind of a weird terminology, but it's how the data is accessed. This is what you want to get as good as possible. This is kind of the meat and the hard thing. And I'm going to spend a lot of time on this one because there's a lot of different values for this. And it can be pretty good or pretty bad depending on it. So I pushed a button and nothing happened. All right. So I'm going to do this in order of worst to best. So the worst type you can get is all. That means it does a full table scan of the underlying table data. Everything else other than all and null uses an index. Null being the fastest one because there is no data access strategy because there's nothing to access. So that's the fastest, really. But so if you have all and you did not intend to do a full table scan, check the tables. Maybe it doesn't have an index you thought it would. One thing that gets folks a lot is that MySQL uses B trees underlying, and a B tree is very good for. I won't go into what a B tree is, but it's very good for range queries. So if you're going from record number 1 to record number 2 to record number 3, it's kind of optimized for that, as opposed to skipping around and doing things randomly. It's a sequential access, and in fact, my ISIM means. Well, ISIM means indexed sequential access method, so MySQL is basically optimized and written to, run really well on things like B trees and spinny disks where you go one next to another. But what I wanted to say here was, if you have an index and it's not being used, it's doing a full table scan instead, MySQL, because it's so fast to do this kind of scanning, if what you're looking for is more than, say, 15-20% of the records, it'll look at all the records. So if you have a database and you're like, well, we have this database of people and we want we have a yes/no question and half the people are yes and half the people are no, or let's say we have a gender database where 48% of the people are male, and 48% of the people are female, and 4% of the people are, trans or unknown, or didn't give us the information, and you're looking for males, it's not going to look at the flag for males. It's just going to do a full table scan because it's faster than getting 48% of the data by an index, because then it has to go to the index structure and then go to the data. It's actually faster for it to go straight to the data. So if you're like, oh, but there's this index it's not using, one of the things to check is how much data is coming back, which is one of the last fields is rows examined. If it has to look at a lot of data to do it, it might not use an index even if it's there. So the next one is, the next data access strategy is index, which means, A, it's using an index, but it's doing a full index scan. So again, full scan, but of the index. So this is, if you have to scan the entire data set, this would be the best data access strategy you could get if you're using a covering index. And a covering index just means that when you're writing a query for a certain thing, that covering index covers the whole thing. It doesn't actually have to go to the data to get what you want. So sometimes it's useful to put this in there so you don't have to go to the data itself. Range is a partial index scan, meaning it scans part of the index, so it just does a range. I think we all kind of know what a range is. And this, you get something with greater than, less than, greater than equal to, less than equal to, that's kind of obvious. Is null, between, or in are also range scans because of how MySQL does the indexing. So between, that's pretty obvious. If it's between something, it means it's greater than, or equal to one thing and less than or equal to another thing. If it's in a set, it can do a range. Sometimes when you use in too, it'll do a range. MySQL 5.6 is getting better about this. But if you have where ID is in 10, 100, 250, it actually will do a range of between 10 and 250 because MySQL is kind of optimized for doing that B tree. It's getting better in 5.6. So yeah, and is null, all the nulls are put on in one part of the index. So let's see. So here's a range query. Select rental ID from rental where rental date between, February 14th, 2006 at midnight and between, that day there. Now, does anyone know why the bottom one is not a range query? If you type this into MySQL and you had the, the database set up, you would not get the type of range. Don't be afraid to make a mistake.
Is it because you're actually using a function on the column?
Yes. 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 Give this man a MySQL book. It's not a range query because you're using a function on the column itself, and MySQL does not have functional indexes, right? So this is not a range because what MySQL will do is say, okay, well, I'm comparing a constant, that date, which is really a string in MySQL, to something that's a function on a field. So I have to go through every single field, run that function, get the answer, and compare it to. Even if it's something like a number field, and you're like, if x plus 1 is greater than 5, right? So if you have a query like this, and it's doing a full table scan or a full index scan, and you're like, but it's just a range, why isn't it using it? Look and see if you're doing something like that, because something like the bottom query can be turned into the top query, and then it can use an index, and it can do a range scan. So, some other things. Subqueries, we'll talk more about subqueries later, but there's an index subquery, which is a subquery using a non-unique index of one table. So basically, if you're doing an in subquery, you're saying where something is in another table or another result set, but that could be non-unique. So you're saying where the first letter of somebody's name is in some kind of set of something else. Whereas a unique subquery is where it's a subquery using a primary unique key of one table. So there's guaranteed to be only 0 or 1 results from that table that might match. And we'll do more about subqueries later. Index merge. Now, index merge is kind of neat. For a while, MySQL had a thing where it could only use one index. So in the Oracle world, people would, there was index merge, and people could just make an index on every field, and Oracle would do the right merging and get the right answer. In the MySQL world, that is not so. And it was not so for a very long time, and even now index merge doesn't quite work like that. Index merge can use more than one index. So if you have an index on name and then an index on ID, and you're kind of filtering out for both of them, it might merge the indexes. It might, it doesn't always. There's an extra field at the bottom of the explain output that gives you a little more information. It tells you what algorithm it used to do the merge, whether it was a union merge, an intersection, or a sort union. And the thing about the index merge is that usually what that tells you is you could have a better index here, but since you don't, I'm going to use these two together, which to me is, is kind of useful. And it doesn't always do that. You can't just, say, well, I'm going to write an application, I'm not going to think about it, I'm going to index every field individually, I'm going to see what index merge is done, and then I'm going to do that. It doesn't work like that. But if you do see it coming back, you can look at it. For example, we have a query here. Select customer ID from customer where last name like Hill % or customer ID is less than 10. It's a nonsense query, right? It's one of the first 10 customers we have, or, the name was like this. It's not really a query that you might be doing in the real world like this on this database, but it illustrates the index merge. So you have possible keys, right? It could use the primary key or the last name index, because that's what you're looking at. And in fact, it uses both, right? The actual key uses both. And at the bottom it says using sort union, it's doing index, last name, and primary, using where. But if you just had an index on both of them together, it would use that, and then it would be a range. Wouldn't be a range query. It would be a faster query. It would be, depending on whether you had a null or not, it would either be ref or null, which is what we'll get to next. So basically, when you see this, to me, and this will probably change in the future, but to me, right now, this means maybe I should think about having a key on primary and the index and the last name together. MySQL also has this thing called prefix indexing. So if you have a composite index, which is a fancy name for an index with more than one field in it. So if you did an index on customer ID and last name together, it matters which order you put them in. If you put the ID first and the customer name, that acts as one index for both, and also the index for the ID only. So the leftmost prefix. If you have 3 fields that you want to index, maybe first name, last name, and ID, right? If you do ID, first name, last name, that acts as ID, ID first name, and ID first name, last name. So all those indexes you can use. So it's actually pretty useful, but it means that if you want something, if you want to index also on the last name, you would have to have 2 indexes, ID, first name, last name, and then just on last name. Ref or null. So this is when you're either joining or looking up, right? You're referring to, I like to think about it, a non-unique index value in another table, right? So what you're doing is you're comparing 2 things. You have, let's say an ID or something, and I think I have, no, I don't have an example of this, but I think I have an example of ref later, which is the same thing, just without null. So basically you're doing, you're joining or looking up a non-unique index type, maybe first name, you're joining or something. Or if you have, the rental thing, you're joining the rental, and if you want to see the rental history, you would join that with the table of people who've rented stuff. But the rental ID it might be unique in the rental table, but it's not unique in the who's rented it table. So the reason that this particular strategy is here is that if, so it's on an indexed field that's either compared with equal to or not equal to. And that last one is a null safe equal to. Null safe not equal to? I would have to look that up. Be useful to have that in my notes, wouldn't it? And it does an extra pass for null values if there might be a null in the result. Now that's important because doing an extra pass through your data means it's slower. So when people say stuff like don't use null unless you need to, this is why, right? Because you could have a faster data access strategy if there was no possibility of null. Okay? MySQL doesn't know if you have any nulls or not. It just knows if you have the possibility of nulls. So it will do this extra pass through even if none of your values are null, if you allow null in the field type. The next data access strategy is the full text data access strategy, which is kind of weird because it's, you're either using full text or not. So it's kind of weird that, it's kind of in this hierarchy of where does it go, because either you need full text or you don't. But here's what a full text data access, here's what a full text query looks like anyway. Select film ID title from film text or match, title description against storm. So this you'd have to have an index on both title and description. So if you wanted to see movies that had either storm, the word storm in the title or description, you would do this. And you can see that the type is full text and it uses a particular key. Full text data access is not, full text searching is not the best. MySQL was not designed to do huge, blobs of text in full text searching. It's getting better. It's actually in MySQL 5.6. You can use EnoDB in full text search, which is so awesome. And it does proximity searching too, so you can see where things are near. It's really kind of awesome. Anyway, talk to me over lunch about that stuff. MySQL 5.6 is really cool in a lot of ways. So yeah, pretty much, it's weird to have this in a presentation on Explain because either you need full text or you don't. So, I can't be like, well, if you make this better, if you made it a query that was an equality query. You can't really make it an equality query. It's not going to work. You can use a like query, but that's never the right answer with. Full text is better than like queries, so. I won't say it's never the right answer. There's probably one case in which it's the right answer, but 95% of the time, not the right answer. Here's the, I should move that slide around. Here's the ref query. I knew I had an example. Here's the ref query. Explain rental ID from rental where customer ID equals 75. Oh, this is a ref. So this is not ref or null. When you have the rental table, you have a rental ID and a customer ID, right? Neither of them can be null. Because if you're having a rental, if this relationship of rental is happening, you have somebody renting something. Neither one of those parts can be null. So when you're looking this up, this is an example of ref. It's like ref or null, but it's without that extra pass for the null data. So it's joining or indexing or looking up values that are non-unique. So in the rental table, right, a customer might rent more than one video, so it's non-unique. So yeah, that's what I'm going to say about that. So yeah, ref is joining, looking up non-unique index values, uses a non-unique key or index or key prefix. Index fields are compared with those. That's the same thing as the slide two slides ago. But instead of saying the best data, instead of saying extra pass for null through, the bottom now says this is the best data access strategy for non-unique values. So if you needed to do that query to find out all of the rentals that one customer did, or all of the history of rental for one specific ID, that's not a unique value in that table. This is the best data access strategy you can get. If you run an explain and you see ref and it's a non-unique thing, you're done. Move on to the next query to optimize. You're done. Because really that's what this is all about, right? How do you optimize your queries using explain? The way that you do that is you have to look at it and see what's going on. Now I have to see what time it is because I have no idea what time it is.
10:24.
10:24. Excellent.
Do you want a 5-minute warning?
No, I'm good. I can take my own time. Except what I don't want is there. That's what I want. I want the window where I'm not going to be distracted by other things. Okay, so what happens if you have unique values? Would be the next one. And that would be EQ ref. I don't know, I think of it as equality ref, whatever. But basically it's for joining or looking up unique index values. Either unique key, primary key. Join uses a unique index or a key prefix. By key prefix, let me go on a little rant between keys and indexes. So in MySQL, key and index are the same thing. And usually they are when people are talking about them. Oh, it's a key, it's an index, whatever. Technically speaking, an index is an implementation detail. An index is what you call the data structure that you do stuff. A key is either a primary key, a unique key, a candidate key, which is a possible primary unique key, or a foreign key. So if people are kind of mixing up key and index, that's fine. Some people won't, and that's where the terms come from. So, the fact that in MySQL, they're mix and match, that's okay. I try to get over it. But they are technically different things. So like if you ever, meet CJ Date and you start talking about indexes and he looks at you funny, because he's all about theory, not about implementation. He's like, indexes, those are an implementation detail. Nobody needs those. If you write your queries right, you won't need indexes. So he's a great guy though. But anyway, index fields are compared with equality, right? And it used to be that there was, not equal to, but that's not going to happen when you have, a unique one, right? Because if you have something in a table, right, and you're looking for something that doesn't equal something, there's probably more than one value, or there's potentially more than one value that doesn't equal. So if this is a really good data access strategy for if you're looking up a unique value. It's not the best one though. So here's an example. So when you have, a rental ID, which is the primary key for the rental table, it's an auto increment number. So if you're saying, okay, show me the return date from rental, where the rental ID is that, because the rental table has rental ID as a primary key, MySQL knows that there will be at most one value for this. There might be 0 values or there might be 1 value. So it knows you can use this data access strategy because it knows that as soon as it finds that 1 value, it can stop. So you can see the type is const. That's not right. The type is EQF. Actually, that's right for that query. Because I was explaining. So this is the EQRef data access strategy. I have this in a join. It's a little more complicated, so I'll go through it. Select first name, last name from rental. Okay, we're getting a person out of this. Interjoin customer using customer ID. Okay. Where rental date is between there. So anything that was on Valentine's Day 2006, I want to know the first and last name of the customers. Maybe I want to give them like a special offer. Who knows? I want a list of their names. So how does MySQL do that? Well, we already talked about the range query. So that rental date, right, the table rental has the rental date field on it. That's using a range to get that. The EQRef, but once it has that, right, so it goes there first. Oh, the other thing I forgot to tell you is that MySQL actually does this in order. So when it's giving you these rows back, where it says, okay, this is table 1 is row 1, it actually does that one first. So it'll go, and it looks and says, okay, what's the best thing to do here? First, I'm going to find all of the customer IDs where the rental date is between, is on, February 14th. So I'm going to find those, and then I'm going to look up the customer name from the customer IDs in that row. So that's what it's showing you here. And so looking up the customer ID from the name, right, the customer ID on the customer table is a primary key. So that's what that EQRef is there. And the key is a primary key. And that's important because the EQRef is only going to happen when you have a unique or primary key. So the fastest data access strategies that you may or may not come across. So const is at most 1 value, which uses a primary or unique key. And what I'm going to do is I'm actually going to move that slide. We're going to pretend like that didn't happen. We'll fix it in post. It's all about, I run a podcast, so it's all about fixing everything in post. And we're going to change this to const. You can't see anything I'm doing. Oh, that's not there. There we go. Oh, wow, this is a big pain. All right, well, I'll move the slide. Fastest data access strategy. Slideshow. There we go. Fastest data access strategy is const. At most, it uses 1 value, so primary unique key, and that's what I was showing you here. I was trying to change the title of the const, where the rental ID is a primary key, so it gives you at most 1 value. So, for example, explain select return date from rental as R, where rental ID equals 1, 3, 5, 3, 4. There is a faster data access strategy than const. Okay, so how can something be even faster than it's a primary key and you're only getting that value? The faster one is actually system, which is the system table, and there's only 1 value. So, for example, this query, you'll never use it, right? Select time zone ID, use leap seconds for MySQL at time zone. But it is technically faster than const. So this is that const one. So there is actually something really cool in MySQL called constant propagation. And the name is kind of a spoiler for what it does. But you might see something that's weird, and it shouldn't be like that, but it's faster than it should be. And this is what happens. So if you have this query, which is select return date, first name, last name from rental. So we're going to get the first name, last name, and when it was returned from rental. Join it with the customer using customer ID. So show me all the people who rented this. Give me the history, right? Did anyone ever have those old school library cards where you had like the name of the person, like the thing in the book that like who checked it out, when they checked it out and returned it? This is basically that for the rental. It's just who checked it out and when they returned it on a particular movie. And so what happens is you would say, okay, well, let's see, what is this explain telling me? First row is a simple, the table's rental. So it's going to do the rental table first. Okay, and it's going to use the primary key. Well, that makes sense because you're looking up rental ID. And that's what you would do too. If you got this query and you'd be like, show me all of the first name, last name, and return date of people who rented out this movie, you would go to the movie and be like, okay, so who rented you? So the movie itself is the primary key, right? The rental ID is the primary key on rental. So it's using that first. And then once it does that, it has every single, it's just a rental ID, so there's only one thing. So the rental table uses rental ID as a filter, and rental ID is unique. So const makes sense. So what about the customer table? What should the customer table be? We're looking up, it's going to be at most one value, and we're looking it up. What kind of data access strategy? It wouldn't be ref or null, because there's no null value if it's a primary key. It would probably help if I gave you a list of them.
Yeah.
Let's see, there was ref or null, there was full text. I'll just do things better than ref or null. Full text, ref, EQ, ref, const, and system.
It's either EQ, ref, or const.
It's either EQ, ref, or const. Now that's actually the right answer. So you would think it would be EQ ref, because that's where you're looking up something that's a unique value. But because the first thing you looked up in the first table, you know there's only one value there, it's going to be const because it propagates that const over. So if you were looking up something, say where rental ID is between 1 and 100, that would be a range on the first one and an EQ ref on the second. Because once it's found the IDs it needs, it's going to then join it to the customer table. But the customer table, each customer ID only will appear once. But because the, let me show you this. Because there is at most one customer ID from the first part, it actually propagates that const onto the second one. So this isn't something you would probably ever question if you saw it. If you saw const and const, you'd be like, okay, I'm done. My work here is done. Let me go to the next query to optimize. But if you wondered why that happened, this is why. Because at most there's one customer ID, which in the customer table is unique and not null. So it doesn't need to do an extra pass through because it's not null, and it only needs to find one result because it's unique. So the really fastest one is no data access strategy, which is when the table is null. And it's the fastest strategy because there is no strategy, right? MySQL is like, no table strategy. You also get that when the where is impossible. So we looked at that before when we saw something like where the rental ID equals 0. But you'll also see that if it can resolve the query by just using metadata. So if you do like an explain select count star on a MyISIM table, you'll actually get null for your data access strategy. So let's move on. That was only like the fourth or fifth, I think it was the fourth field that you get. There's other things. So the first one, we saw this in some of the queries, right? You have the possible keys, which is the list of things that MySQL thinks it might use. Now, if you have an index and it doesn't even show up in the possible keys, you got to really take a look at what's going on with the query. Maybe you're using, like a functional index. Maybe you're doing a full table scan or something like. The point is MySQL is not even considering that index. So look and see. Maybe the index, you have a composite index, an index with more than one field, but you've put them in the wrong order. So MySQL is not even considering using it. Stuff like that is a real kind of warning flag when you're like, why? Like whenever you want to rip your hair out with MySQL, or at least I found this, whenever I want to rip my hair out with MySQL, it's usually because I wrote the query wrong. It's not like MySQL's fault, it's mine. Administering it is a different story, but queries, it's usually like, it's being a computer again. It's doing exactly what I told it to. The key field is what key it actually used, or in the case of index merge, it gives you a comma-separated list. The key len is the length of the key. So longer keys take longer to look up and take longer to compare. Again, that's just a fact. It's not saying that everything should be as small as possible. It's just saying that, hey, it takes longer to do that. The ref field shows what's compared, either the field name or I think it's just the word const, and I have an example on the next one. So if you think that, look closely if an index you think is possible is not considered. So why are you doing that? So for example here, what was I showing? Yeah, I mean, like you can see the key length is 8 on the rental date because it's a date, so dates are 8 bytes long. It's actually date time. Date times are 8 bytes long. Key length on the customer ID is 2 because it was using it wasn't using an int, it must have been using a medium int. Anyway, key length is 2 bytes on the primary key field. But this gives you, and here's the ref. So ref here is null, and ref here is sequila.rental.customer.id. So when you're joining, right, the customer ID to customer, it actually shows you that it's joining from the rental table, the customer ID. So that's pretty useful. That kind of field can be the key to if it's using a wrong index. You'd be like, why is it using the wrong index? Oh, it's joining on something totally different. That happens a lot when you use, I'll go on a little rant about different ways of writing queries. So you can see all of my queries I've used inner join. When I have like table A, inner join, table B. And I do that because I like to write self-documenting queries. And what I mean by that is, if you look at this query, inner join, that's not any special word. It means nothing. I could say inner join, and if I didn't have a where clause, or if I didn't have the using clause or anything in the where clause to change things, it would do a Cartesian product. You can say cross join and then have a using clause. I could put the word cross instead of the word inner. So I could say cross join customer using customer ID, and it would have the same result. So the word means nothing. The word inner versus cross means nothing, or I could leave it out completely. But to me, when I look at this query, if it's actually doing a Cartesian product and it says inner join, I know that the developer meant they wanted to do an inner join. Conversely, if they're doing a Cartesian product and they say cross join, I know that's what they intended to do. The other thing is, does anyone here use commas to separate tables? Okay. In MySQL, I want to say 4.1 and up, precedence changed. So it used to be that if you used inner join, like if you mixed inner joins and commas, so you could say, I could have said explain first name, last name from rental, comma, customer, where customer.customer ID equals rental.customer ID and rental date between that. That format is perfectly acceptable. I personally don't like it because then your where clauses get big if you're joining 4 tables, and it's really easy to miss the fact that you forgot one of your join clauses in your where clause, right? So if you put the joining in the where clause and you have 4 or 5 tables, it could be easy to miss. And also, I sit there, I'll print out a query and I'll be like, okay, rental join customer. Where's the thing in the where clause? Okay, cross that out. I've used that. Because that's kind of the only way I can really, I really have to do that, where I'm like, okay, that line's joining that. If you use this, so it's ANSI style versus theta style. I think that's ANSI style when you put everything in the where clause, and this is theta style. It could be opposite, but you're nodding your head. Okay. So yeah, if you want to use the real words, the real terminology, theta versus ANSI. This is theta style, which is, you have a using clause there, or you can also have an on clause. So you use the word using when the name is the same in both tables. So customer ID is the same in both tables, and so you can just say using customer ID. Or you could say on rental.customer ID equals customer.customer ID. And that makes it a whole lot easier when you have 4 tables, because you're saying like A inner join B on this, inner join C on that, left join D on that. So that's just a little tip that I like, and again, it also really helps you to know if you miss a join clause there, you don't have an on or a using next to something, it's really easy to figure out because it's right there. So that's just my little, everyone has their own different styles of coding. I personally like to do the theta style, and that's in all of my examples because I know people copy examples. So that's. It's funny, I actually wrote a book, and I had we were writing the book on partitioning, and it was my co-author's chapter, and he wrote it, and I was looking at it, and I'm like, dude, you just wrote like the worst example ever. And he was like, nobody's going to copy the example. And I was like, oh God, man, like everybody copies the example. That's what they do. Like you could, like in a couple of years, you could go searching through databases and find the exact table name you used, even if it was something weird. People copy examples, so always have good examples. You'll notice that none of my examples have select star in it. There's a point in that. It's like no select star unless you need it, unless that's what you actually really want, even if you add fields for the rest of your life. I have strong feelings about things. You know, it's so funny too, I'm just looking down and there's actually a clock on my computer, so I don't need my phone, but it's all about knowing your technology. So, ref is const. So here's an example where the ref is const. So before we had ref could either be null or the customer, the field name. But I said it could also be const. So here's something where the ref is const. You're just comparing it to a constant. That's all that is. Approximate number of rows examined is the approximate number of rows examined. That's what you get, folks. Yeah, it really, really is tricky. And it's the ones examined, not necessarily the ones returned. So if you're looking at a lot more rows than you think you should be, again, look and see if you're doing what you think it should be. Now, here's something interesting. What if you have a limit on your clause? Let's say you select first name, last name from customer, limit 10. Now, first of all, you'll notice that the type is all. There's no where clause. There's no filter on this. So it's going to look at every single row in the customer table, which maybe is what you wanted, maybe not, but that's what it's going to do. But you can see limit 10. Now, if you looked at this, you would say, well, it would examine 10 rows because it's going to look at the first 10 rows, and there's no filter, so there's nothing for it to do. Limit doesn't change rows, even though it actually affects number of rows examined. So it can be a little misleading, and I think that kind of rows is some kind of hack in MySQL that's just kind of like, well, once you've got all this information, then just like do some math and get the approximate number of rows determined, as opposed to some actual logic that says if you have a limit, right, you're only going to need the first 10 in this case. And it's also an O of n kind of a calculation, right? At most, you're going to need, even though we know you're going to stop at 10 rows, at most you're going to read all the rows. So, extra. There's a lot of different extra values, and did I show you here? Like here, the extra, there's nothing in there. But there can be a lot of things in there. For example, there can be good things, bad things, and neutral things. And sometimes you can't avoid the bad, but sometimes you can. So I'm going to talk about some of the extra stuff in there. For example, if you have the word, index used, it means you've used an index, which is usually a good thing. You could see, for example, that index used is not in this one because we didn't use an index, because it's a full table scan. Or it's called using index, I think. Distinct means that it stops after the first match. If you say, like, select distinct first name, it's like having a limit. Once it gets there, it's done. Full scan on null key is bad. It means that it's doing a subquery lookup with no index. So there's a null key, and then it's doing a full scan. Impossible where notice after reading const tables. That could be good or bad. What that means is I'm not going to return any results. Usually when you're running a query, you kind of want results. Null is a valid result. But if you see impossible where, look at it and be like, oh, okay, because you might have like a less than when you wanted a greater than. That never happens.
Oh, never.
It can say no tables used. If you do explain 1 plus 2, you'll see no tables used. Oh, and the other thing that I would recommend is, like, try this out yourself. Go, like, do explain 1 plus 2. Do explain select sleep parentheses 1. Okay, what's sleep? Sleep actually just sleeps for however many seconds you put in the middle. Oh, it's awesome. If I'm like trying to like get some stats and I want like a running monitor, I will just do like, show slave status, select sleep 1, show slave status, select sleep 1, so like it can be running in a window over and over and over. So more extra. Not exists. It stops after the first row match for each row set from previous tables. That's a little complicated. If you think about what not exist means, is that as soon as you find something that exists, it's not going to bother looking at the rest of the set because you're looking for if it doesn't exist. So if it exists in the set, you're like, well, I don't need that set. It exists. Let me go to the next one. So again, it's whether or not that's supposed to be done. So if you're having a complicated series of logic, that could be there. I don't know if I've ever really done much with not exists. It's not really a red flag for me. That doesn't necessarily mean that it shouldn't be for other people, but usually, you get enough with like, oh, it's not using the index you want to use. Select tables optimized away. Whenever you see something like optimized away, that's good. It means that it didn't need to go to the tables. It went directly to the index of the metadata and it was done. Range checked for each record, index map n. Now this is actually kind of interesting, and I don't know if I've seen this in the wild or not, but it's actually, I've seen it once actually in the wild. And what it means is that it checked every single range that you had, it checked it, and it can't think of a good index now. But maybe when it's executing the query, it will think of a good index. So it kind of depends on the values of what you're getting. So if you're doing like a join, right, it might depend on the stuff you get for the first part of the join, what it's going to do with the next part. The only place I saw it was like a complicated query of like 10 different tables. So, but it was kind of like interesting to be like, okay. Using, so there's a whole bunch of using, there's using index, which uses only the index, not a table read. No, that's not true. Yeah, that's not true. It actually, I believe using index means it just uses the index. It's not a full table scan. I'm going to look that up, and I have no idea. If I put it there, I'm going to say when I was writing these slides, I researched it. So I'm going to say this is right. As opposed to what's in my brain right now. So uses the index only, no table read, covering index is good. But I will make sure to research that and tell you if it's right or wrong. Using file sort means it does an extra pass to sort through the data. Now, using file sort has nothing to do with files. File sort is the sorting algorithm it used. Has anyone here like taken an algorithms class? File sort, bubble sort, yeah, all that stuff. That's what that means. So even though like a lot of people are like, oh, it's going to a file and sorting. No, it's not going to a file. It's using the file sort algorithm, which is still not good because it means it has to do an extra pass through the data. So if you see that, what can you do about it? Well, maybe you can either use a different index or change an index so that the sorting order is in it. So for example, if you're selecting a bunch of IDs and then ordering by, or let's say you're selecting all the blog posts by one person, and you're ordering them by date, right? You want to see all the blog posts of one author, but it's in descending date so that you get today, then yesterday, then the day before, right? That's a pretty standard kind of query that you would do. Instead of just having an index on the author, you might want to have an index on the author and then the date. And that way, it'll get the index in the author, and it will have it already in the date order. Indexes are B trees, and the way that you could think about it, if you wanted to, is think about, I'm so old. You remember when we used to have these paper dictionaries when you wanted to look something up? Remember that? Or like the encyclopedia? Remember that? And remember how like you'd open the book, and you'd always like open it to like the middle or whatever letter you thought, like if you were at A, you'd open it to like the beginning. And then there were these things at the top that were like, okay, here's like aardvark and here's apple or whatever, and you'd be like, oh, well, my thing I'm looking for, Asgard, so that's after apple, so I have to turn the page. Those are indexes, right? So that's basically how you can think of MySQL B-tree indexes, is that, it'll go somewhere and it'll say, okay, what's the first letter? A. Okay, well, am I in the A section? If I'm in the M section, I have to go, to the left. I have to, go there. What about the next, S? Am I there? So that's the same kind of thing you can think about with having more than one field. So say, okay, did I match the author yet? Yes, okay. Now everything is already in order, right? Just like in the dictionary, once you do the first letter, the second letter is also ordered. So that's the same kind of thing. And it also helps when you need to remember things like prefix indexing, right? So it's really easy to find all of the letters that begin with ed, but really hard to find all of the words that end with ed in the dictionary, right? Same thing with MySQL. MySQL can use an index if you're searching for the first field in the index, but not if you're only searching for the last field in the index. It just doesn't work that way. That also works with like and percent and using indexes too. So if you're looking for things that start with something, that's great. If you're looking for things that end with something, not so great. So where was I? Right, extra. So file sort. So you can use an index for sorting. Index for group by. Index or group by means it used an index to fulfill a group by or a distinct, because distinct is underlying, it just groups it and finds the distinct ones. So that's actually a good one. Temporary means an intermediate temporary table is used. And now I have this like in smaller font that it's bad, because this is one of those things that it's going to happen, it's probably going to be unavoidable. Sometimes you have so many results that you're throwing together, it needs an intermediate temporary table. It happens. It's okay. Like, maybe you can optimize that away, maybe you can't. You can definitely optimize whether that temporary table goes to disk or stays in memory. That's an administrative parameter. But, sometimes you need an intermediate temporary table. Information schema. So this is interesting. Does anyone here query the information schema at all? I do sometimes. Okay. Yeah, because people come to me like, so, I have this query and it's not working, and, it's probably something with this field. And, they don't give me the query. And I'm like, well, I need to find what table that field is in. So I query the information schema. And now some people are like, well, if you query the information schema, it could crash your database. And I was like, oh, let me go investigate this, because that seems like an urban legend to me. And that kind of thing is not on Snopes. I need to write to the Snopes. Like, how come that's not on Snopes? I don't know. And what happened was I actually found it when I was researching this stuff. So if you have extra information schema, if you're querying the information schema, you'll see some of this. So for example, scanned N databases. Now N is only 3 different values. It's either 0, scan 0 databases, scan 1 database, or scan all databases. So if you are, let's say, finding a schema with a certain name, right, it might scan 1 database or it might scan them all. And that's pretty good. It's pretty fast. It's only scanning, right, the databases. It's fast if it's only scanning 1 database or 0 database. If it's scanning all the databases, it could take longer, and we'll get into why it might potentially crash in a second. Skip open table means it's the fastest. You don't need to open any table files. So the .frm file in MySQL is the format file of the table. It's where the schema is stored. It stores, the indexes and the column names and all that kind of stuff. But if you're looking for a table name, for example, it doesn't need to open any table files. You can get that just by looking at the file names. Open FRM only means it only needs to open that FRM file. So if you're looking for column names or the indexes, it can do that. If you're looking at triggers only, it'll only open the trigger file. But you could have something like open full table. Open full table means it needs to open all of the table files, and it's the slowest. And when people said, I ran a query against information schema and it crashed, it's because they were running a query that scanned all the databases in open full table. And they had like millions of tables. This is not just something where if you do that. So if you're worried about that kind of thing on your system, you can run an explain, and if the explain shows that it's open full table and scanned all databases, then maybe you might want to consider it, if you have millions of tables. Now, when is open full table used? It's used for things like you can actually get the approximate number of rows in a table, or the cardinality of an index, things like that. So there are certain reasons you might want to do it. Most of the time when we're looking at information schema, we're like, what table is this column name in? And it's not going to open full table. So most of the time you're pretty good. So myth busted, or myth approved, right? Because you can actually, what do they say when they test it and it's real? What is it? Confirmed. So yeah, it could be confirmed because it does happen, but it's certainly something that's very rare. I promised we would talk about subqueries, and we will in these last 5 minutes. So here is a subquery. First name, last name, email, that's in. So what's the middle inner query here? Customer ID from rental as rental subquery, return date is null. So give me all, and I want their first name, last name, email. So I'm going to email all the people that have a video they haven't returned yet.
After 6 years.
Not after 6, after 6, I don't know, maybe it's a special. What if they rented it yesterday? There's no date filtering, right? So maybe I'm just be like, dude, if you return your movie today, we got a special going on or something. Or, hey, Slacker, return your video. Either way. So that's what this query is doing. And here's something you might see. In the primary table, the first table, the primary one, is customer outer. And I alias that name because I like to see outer in my subqueries. And that's doing, oh look, a full table scan. That's not so good. And then the inside is a dependent subquery. Now, every single one of us took, what, 3rd grade math where we learned parentheses, right? And if we were the MySQL optimizer, we would see the parentheses and we'd be like, dude, just get all the customer IDs that haven't returned a rental date and then get the first name, last name, email. Why don't you do that? Well, MySQL is not math. It doesn't do the parentheses first. It's doing a subquery. And what this is, because this is a dependent subquery, it's actually saying, okay, let me get the first name, last name, and email from the customer. So it's going this full table scan. And for each row that I get in this customer table, first name, last name, email, I'm going to get the customer ID from, I'm going to join the customer ID from rental. I'm not going to join, it's a subquery. But I'm going to look at the subquery to find that. So it's actually doing it backwards. It's going through every single row. It's doing a full table scan, every single row, and doing that. Now, why is it doing that? And it's doing a full scan on null key. Did I even say using where, it's using a where clause? If I didn't, it's there. That's one of those basic things that, like, if there isn't a where clause, I'm going to notice anyway. The extra field isn't going to help. But there you go. So if you saw this is where you start ripping your hair out, like, why is MySQL doing it? You could actually make this better by changing this to a join. This is just a join, right? There's no reason this couldn't be a join. I even said join when I was talking about it, where you could just say, look, just join the tables on customer ID. And there's no need to do it. And then it would use the right indexes, and it would do the right thing. So sometimes it's a matter of how you're thinking about it. If you're thinking about it in a procedural way, this is a very procedural thought. I want to get all the customer IDs, that's my inner query, and then I want to do, that's my outer query. Whereas if you just thought declaratively by saying, give me the first name, last name of emails where these two tables join and match. That's more declarative thinking. Which, you know, I can do, I'm a DBA and that's my forte, but you don't want to see my procedural code and you definitely don't want to see my object-oriented code. So MySQL subqueries. Avoid unoptimized subquery, like that one. Dependent subquery actually means that for every row in the outer query, it's going to run the inner query. So here's the thing. With this query, it runs this query 541 times, approximately. Yeah, not desired. This is when people are like, I optimized this query and it used to take 7 days and now it takes 5 minutes. This is the kind of stuff they're doing. They're like, here's the secret. All we did was change like a subquery to a join. We did like no work. No, it's not that we did no work. But I mean, like, you know, it's not like we tweaked 70,000 knobs. We just rewrote the query and there you go. Or added an index in some cases. Or did both. So avoid unoptimized subqueries. Not all subqueries are unoptimized. Although when they first came out, that was true. So if you hear like, oh, never use queries in subqueries in MySQL, that's why. But, you know, that's so like 10 years ago. So derived tables. A derived table is a subquery in the from clause because it's a derived table. It's a made-up table. It's a table that's it's a subquery in the from. It's a query itself that produces a table in the from clause. They might be, you could, if you have a derived table and you want to make it better, you could turn it into a view, you could turn it into an intermediate temporary table. In some cases, like we just saw, subqueries can be turned into joins, and subqueries are getting better all the time. And different forks do different things with subqueries. MariaDB is doing some great things with subqueries, making them a lot faster. And again, subqueries used to be dependent subqueries. It's getting a lot better. The good news is that because subqueries were so bad in the past, there's a lot of knowledge out there on how to turn your subquery into a join because they were so bad. More explain values. Explain partitions. Instead of saying explain select, if you have a partition table, you can say explain partitions select the query. And what that adds is a partitions value that shows a list of partitions to be checked for that table. So if you're only using the first 3 partitions, it'll show you that. And if you accidentally do it on a non-partition table, things don't blow up. That field is null. There's also explain extended, which gives you 2 things. One, it shows you the filtered field, which is an approximate percentage of how many of the examined rows are returned. And then it also will show the query after the optimizer is finished with it with show warnings, which I think is uninteresting, but I'll show you it anyway. So here, right, we have explain extended, select customer ID from rental where staff ID equals 2 and inventory ID is less than 100. Again, a nonsense query. It's just the first 100 movies we had, and if the staff member number 2 rented it out. But the idea is, if you see the rows here, right, there's 300, it's using an index, the inventory ID. It's going to examine approximately 326 rows, and it's filtered 75.15%. So it's going to send back approximately 75% of the rows it examined. Now that's good. You don't want to examine a ton of rows and only return a few, okay? Because it's already using the index to pick what it's going to examine. You want a higher percentage here. Frankly, I don't think I've ever used that to actually make a decision, but I may also have some things that seem obvious to me that may not be for others. So that trick might work for other people. It's not something that I necessarily look at, but it can be pretty useful. And let's see, explain extended. So if you did show warning, so if you look here at the bottom, it says one row and set one warning. And here's what the query actually looks like. So you can see it's expanded it, it's got parentheses, it's got backticks to escape everything. Everything is now with Sakila because it's the database name, is sakila.rental.customer ID. So again, I think this is uninteresting. There's probably somebody out there who's had a huge revelation by looking at this, but it's not me. More explained information, there's actually a cheat sheet, which is actually pretty cool. So all of, if you don't remember the order of the, what's best, what's worse, from all to index to whatever, there's a cheat sheet on that, and also all the other fields. I wrote a book, it's called the MySQL Administrator's Bible. There's a whole 24 pages on explaining. And if you wanted to get the Sakila sample database, there it is. The slides are up at bit.ly/explain slides if you really want it. And in the plus 2 minutes I have, the negative 2 minutes that I owe you guys, if you have any questions, comments, or feedback, find me at lunch, or send me questions via email or Twitter or whatever. Thank you.